All right, this is it. We've made it through 12 chapters with a little bit extra in 13 and 15. This is 12.6, the volume of a sphere. So the volume of a sphere is equal to 4/3 of the product of pi and the cube of its radius. So I'm actually going to link a video for this one. I'm not going to embarrass myself by pouring water all over my floor anymore. I'm going to post a video that shows you where the volume of a sphere formula comes from. The other thing that is mentioned in 12.6 is what's called Cavalieri's principle. So Cavalieri's principle says if two solids A and B can be placed with their bases coplanar, and if the area of the cross-section of A is equal to the area of the coplanar cross-section of B, then A and B have equal volumes. So I'm going to show you a GeoGebra that will help you see this a little bit better. So here I have two triangular prisms. Their areas of their bases are the exact same. They have the exact same cross sections. You can see there's all these slabs that line up. So all the cross sections of the first figure are equal to the cross sections of the second figure. And these two figures also have the same height. So you can see that no matter how I move these stacks of slabs, so even if it's oblique, so this would be an oblique prism, this would be a right prism, or I can even make it look like this, these two figures will always have the same volume. So that is how Cavalieri's principle works. Okay, so let's try some practice problems with spheres. So see if you can find the volume of a hemisphere, so half a sphere, with a radius of 6. So instead of finding the volume of a full sphere and then halving it, I want to know what the formula for the volume of a hemisphere is. So I know that I have to take the total volume formula and half it. So this actually ends up simplifying to 4/6, which is just 2/3 pi r cubed. So that is the formula for the volume of a hemisphere. So now I'm going to plug in to my formula. All I need is my radius, which I'm told is 6. So this is going to be 2/3 pi 6 cubed. Make sure you don't square it by accident. And when you put that in your calculator, you are going to get 144 pi units cubed as your volume of the hemisphere there. All right, one more. If the volume of a sphere is 288 pi, see if you could find its surface area. So before I can find the surface area, the thing I need the most is the radius. So I set my volume equal to my volume formula, and the pi's are going to cancel out. If I get rid of the fraction and multiply both sides by 3/4, I'm going to get 216 equals r cubed. And then I need to find the cubed root of 216. So there is a cubed root button on your calculator, depending on which one you have. So if you have the yellow one, you would put the 3 in first actually, and then press second and the little chevron key, I guess you would call that. And then you can put in 216 and you'll get 6. So my radius here is 6. Now I can plug into my surface area formula. So surface area of a sphere is 4 pi r squared. So I'm going to do 4 pi 6 squared, and I will get 144 pi as my surface area. And that would be units squared because we're talking about area. All right, so that is the end of chapter 12. I will see you in our final office hours together.